Okay, so now we're going to take a look at some of the different logical operators that we can use with our Boolean expressions. So there are going to be some instances where you need to include some more complex logic than just a single yes or no, so maybe just a single true or false value based on just a single Boolean. You may need to address multiple Boolean expressions at once, or you may have situations where it's more effective to check if something is not true. So in those cases, what we're saying is maybe you want to check multiple different Boolean expressions all at the same time, or when it comes to checking if something is not true. So we've seen with our if statements, we're saying if something is true, we want to go ahead and execute some code conditionally. Maybe there are going to be situations where it is more effective to say if something is not true, then we'll go ahead and execute those statements. So our logical operators are going to be used to connect two or more relational expressions, you can think of those as just Boolean expressions, into one, or to reverse the logic of an expression. It is important to keep in mind that the operands used with these operators must be Boolean values. So whenever we're dealing with the operands, the values that are going to be on each side of our operators, we need to make sure that those evaluate to some Boolean literal, so they'd have to evaluate to either true or false. You want to avoid making the mistake of using something that would evaluate to just a number or just maybe a string or a char. So specifically, they need to evaluate to either true or false, so that then we can combine them together to get just a single true or false value. So the different operators that we have to work with are going to include things like logical AND, which has that double ampersand. There's going to be a logical OR, which is going to use the double pipeline character. So in a moment, when we start doing a little bit of programming, we see a little bit of code with this. I'll kind of explain where to find that key on your keyboard. And then we're also going to have logical negation, which is going to be a single exclamation point. And we've seen a little bit of this before with the not equals with our comparison operators. So we saw that before. We're using the exclamation point to indicate not equals. So if you want to do just simple logical negation, we're going to be using that character by itself. So the next thing that I want to get into is going to be the truth tables for each one of those three different logical operators. And the purpose of these truth tables is to be able to see the different combinations of true and false values and what the expected output would be. So in this case, we're looking at the different combinations with the logical AND operator, and then we're seeing what the output's going to be with those combinations. So we've got true and false, false and true, false and false, and then true and true. And if you see with the outputs that we have on the right column, we're getting false for the first three cases, and then true for the last case. So based on this, what you can probably figure out from this is that if either one of the expressions by itself happens to be false, then the entire expression is going to be false. And so we can actually kind of demonstrate this with just some simple non-coding examples. So I'm going to go ahead and type out a couple of different sentences on this text editor, and we can actually see, based on whether or not those statements are true, what effect that has on the entire sentence. So the first example I'll go ahead and use is making both of these true. So we'll see one condition and another condition. So we'll do the grass is green and the sky is blue. So with this one, you see we've got two different conditions that are technically going to be true most of the time. So if both of these conditions are true, we would say that the entire statement is true. We can also consider the opposite case. So if we say the grass is not green and the sky is not blue. So if both of these are going to be false, so we've got the grass is not green, that's false, the sky is not blue, that's also false, we immediately recognize that the entire statement is false. And then the other two cases that might not be quite as clear as these first two are when either one of these by themselves is false. So maybe the first one we can do is the grass is not green and the sky is blue. So it might be true that the sky is blue, but because we're using a logical AND for this, so we're trying to say AND on these two different conditions, we're essentially trying to make the argument that both of these things are true. So if we're doing this, but one of those things is not true, then because of that, the entire sentence becomes false. And the opposite would also be true. Say the grass is green and the sky is not blue. So again, just like with the previous example, one of these conditions is false, and that thus will make the entire sentence false. So for the next truth table, we're looking at logical OR. We're going to be using that double pipeline character for the operator. So in this one, we're saying true or false, false or true, false or false, and true or true. And with this one, we can see kind of the opposite. So in most of these cases, we have true. There's going to be one exception to this. So we've got true or false, that evaluates to true. False or true, that's going to evaluate to true. False or false, that's going to evaluate to false. And then true or true, that's going to evaluate to true. So in this case, the only time that the entire expression is going to evaluate to false is going to be if both of our conditions are false. So then what we can go ahead and do is put together the set of sentences for this logical OR operator as well. So we'll go ahead and minimize this. Come back over to the text editor. So for the next set, we're going to go ahead and include these same statements here, but we're going to use OR instead of AND. So we'll start with the first one again, just do all true. So we'll say the grass is green, or the sky is blue. So in this particular case, we see that both of these conditions are true, so the entire sentence is going to be true. So pretty straightforward case there. Next one, we'll go ahead and do both false again. So say the grass is not green, or the sky is not blue. So in this case, both of these are going to be false, so that makes the entire sentence false. So just like that case we just looked at, this one's also pretty straightforward. So we'll also consider the two cases where only one of these conditions is false. So we'll say something like the grass is not green, or the sky is blue. And so for this case, we see that one of these conditions is false. The grass is not green, that's going to be false. But because we're using an OR, this is essentially saying that we can have just one of these be true, or we can have the other be true, and then that makes the entire statement true. So it's kind of a choice of sorts. So because one of these is true, the sky is blue, that's going to make the entire statement true. And then if we do the opposite, that's also going to be true. So if we say the grass is green, or the sky is not blue. So in this case, again, only one of these conditions is going to be false. The sky is not blue. But because the other one is true, and we still have that choice that we get to make, that's going to make the entire sentence true. And then the last truth table that we'll take a look at is going to be for logical negation. So it's going to be that exclamation point operator. And for this one, we see we've got either not true or not false. And essentially what that's going to do is just invert the logic. So it's going to switch it from true to false or from false to true. So if we try to incorporate that into the statements we have right now, we could imagine that we've got each of those individually being true, and we're just going to switch them to being false. So the way we might approach this is we've got our statement, something like the grass is green, and to change this with logical negation, we're just going to put in the word not. So we'll say the grass is not green. The same thing with the sky is blue. We want to apply some logical negation to this. We're just going to invert it and just say the sky is not blue. So now we'll go ahead and take what we've seen so far and apply that to our code that we've got. So we're going to use pretty much the same code that we already saw before with our conditional code example. So we're going to create our two booleans, is raining and is thundering. For this example, we could initially start them off as being true. We're then going to do a couple of different statements. So this first one is going to say if it is raining and it is thundering. So if both of those statements are true, that entire expression is going to be true. and then we'll go ahead and execute the conditional statements that we've placed into that if block. So in this case, we would say it might be best to stay inside. On the second example, we're saying if it is not raining, so we're going to use the exclamation point for the logical negation operator. So if it is not raining, then that would mean that it's a nice sunny day. So we'll go ahead and print out that statement there. And then for the last one, we're using kind of a combination of these. So we're going to say if it is not raining and it is thundering, we're going to print out the statement there might be a thunderstorm soon. So let's go ahead and minimize this. We'll come over to NetBeans. We'll go ahead and put together our project. So we're going to go ahead and create a new project. This will be a new Java application. Click Next. For this one, we'll go ahead and make the title Logical Operators. And then we'll go ahead and finish. And so inside of our code, we'll go ahead and remove all of the extra comments that we're not going to need. And so right here, we'll go ahead and put in our two Boolean expressions, or the two Boolean variables that we're going to need. So we're going to have is raining. This will initially be true. And we'll have Boolean is thundering. We'll also have that set to true. And then right here, we'll go ahead and put in the first of those conditions that we're checking. So we're going to say if it is not raining. So, or let's see, the first one we're going to use is going to be the combination. So we're going to do is raining and is thundering. So we're going to say is raining. We're then going to use two ampersand characters. So it's going to be shift and the 7 key. And is thundering. So if both of these are true, then we'll go ahead and print out the statement. It might be best to stay inside. Go ahead and save that. And so if we go ahead and run this with both of these being set to true, then we're going to see that statement print out to the console. But if we change these both to false, we're going to save that and run it, then we're not going to see that statement print out. So this is going to be essentially equivalent to what we saw before. If the Boolean expression right here is false, we're going to ignore the statements that we've put into its block. So in this case, just this one statement here. And then one of the other things to note, because we're using logical AND here, if we make either one of these true, but the other is false, so say we do something like is raining is true, but is thundering is false, well, because one of these is false, and we're using logical AND, the entire expression is going to be false. So if we run this, we will again not see anything print to the console. We're going to ignore that print statement. And if we do the opposite, so we make is raining false, but is thundering true, then again we're going to get the same output, which is nothing printing to the console. We're just going to ignore that statement there. For the next one, we'll take a look at logical negations. We're going to use the exclamation point and then say is raining. So essentially the way that we would read this, we're going to say if it is not raining, then we want to go ahead and execute some statement here. So if it is not raining, we'll say system.out.println. It's a nice sunny day. Go ahead and save that. So the way to make this true is to make sure that is raining by itself is false. So if this is false and we negate that, it's going to be switched to true. So we see right here, right now it is false. So when we do this right here, go ahead and run that. And we'll see that this ends up being true. So we're going to print out it's a nice sunny day. So just keep in mind that when you're using this logical negation operator, that the thing that you're negating, this portion right here, that would need to initially be false in order for the entire expression to become true. And then finally, we'll go ahead and combine these together. So we're going to do if it is not raining. So say if not is raining and is thundering. Then we'll go ahead and print out that last statement saying that there might be a thunderstorm coming. So right here, the exact statement is going to be there might be a thunderstorm soon. So go ahead and put that there. And for this one, we have pretty much the same process as before. Again, this portion right here is only going to be true if this is raining is initially false. We're going to be inverting the logic there. And we also have to make sure that is thundering is set to true. So if we take a look up here at our two Boolean variables, we see is raining is false and is thundering is true. So that's going to match up with what I was just describing, which means that this is going to execute as well, and we're going to get this statement. So if we go ahead and run it, we'll see we've got both this condition and this condition being true. So we get both of those statements. It's a nice sunny day, and there might be a thunderstorm soon. And then one additional one that I'll go ahead and include. Let's say that we want to include one with logical OR, just to get an example of that too. So let's say that in this case, I'm going to check to see is raining or is thundering. So in either one of those cases, the statement that I'm going to go ahead and use here, let's say bring your umbrella. So if it is raining, then obviously we want to bring our umbrella. Or if it's thundering, we're probably going to need it later, so we should just go ahead and bring it just in case. So let's say is raining, and then for the logical OR, it's going to be shift, and then it's going to be the character that's just above your enter key. So that's going to be where you find that pipe character. So we're going to say is raining or is thundering. And we'll go ahead and say system.out.println, bring your umbrella. Go ahead and save that. And so for this one, this condition is going to be true if both conditions are true or if either condition is true. So in this case, we see is thundering is true, so that's going to match up right here. That'll make that entire expression true. So if we go ahead and run this, we're going to see bring your umbrella at the very end. And if I flip this, so I make this true now, and I make this false, this is going to make a couple of these different expressions false, except for this very last one. So we go ahead and run that, and see now we get bring your umbrella there. And then finally, if we did something like making both of them true. So if we make both of them true, we're going to see this one right here, is raining and is thundering. It might be best to stay inside. That's going to be true. So we're going to see that statement print out. And we're going to see is raining or is thundering. That's going to be true because both are true. So we're also going to see bring your umbrella if you actually intend to go outside. So the next thing we'll talk about is going to be some of the different rules related to our logical operators. So one of the things to note about Java when it comes to the binary logical operators, so that's going to include your logical AND and your logical OR. Those are your two binary logical operators. You recognize that they're binary because just like your binary math operations, they have two operands, so something on the left-hand side and something on the right-hand side. So our binary logical operators are going to perform what is known as short-circuited evaluation. Basically what this means is that if the overall result, so the entire expression, if we know if that's true or false based on just the first operand's value, whether that's true or false, then we don't even need to look at the second operand, so we're just going to ignore that. So in the case of a logical AND, if the first operand is false, we already know that the entire operation or the entire result for that is going to be false. It doesn't matter what the second operand's value happens to be. So we're just going to ignore the second operand, and we're immediately done evaluating that expression. And then with a logical OR, if the first operand is true, again, the entire result, we already know what it's going to be. In this case, it's going to be true. So we don't have to really worry about what the second operand is. So we're just going to ignore that and already be done with that evaluation. So this short-circuited evaluation basically allows you to look at just one operand, if possible, and immediately complete that evaluation process. So another rule that we want to address is going to be this idea of precedence. So now that we've seen a couple of different kinds of operations, so we've dealt with things like the combined assignment operators, we've also seen our comparison and logical operators in this chapter. We can now take a look at the overall order of operations for all of the different types of operations that we've seen. So at the very top, the highest precedence, we're going to see things like negation. So it's going to include either unary negation, which refers to making a number negative, or our logical negation that we just saw, so being able to convert our Boolean expression from true to false or from false to true. Underneath this, we're going to find our multiplication, division, and our modulo or modulus operator. Underneath that, we're going to have addition and subtraction. Underneath this, we're going to start to see some of our comparison operators. So we're going to see our less than, our greater than, our less than or equal to, and our greater than or equal to. Underneath this, we're going to have our equality, so equals and not equals. So we'll see that those actually have a lower precedence than any of the other comparison operators. So kind of an important distinction to keep in mind there. Underneath this, we're going to see our logical and, then we're going to see our logical or. So those actually have a different precedence. Logical and actually takes precedence over logical or. And then finally, the lowest precedence is going to be with our assignment and combined assignment operators. And those having the lowest precedence makes sense because of the fact that you don't really want to assign something to a variable until you've completed all of the other operations in that statement. So it would naturally make sense that you would want this to be the very last thing to happen. So given this precedence, we can take a look at some slightly more complicated examples. So in this particular case, I'm going to take a look at a practical example of using a combination of some comparison operators and some logical operators. So we can use this mixture of logical and comparison operators to determine if numbers are within or maybe outside the boundaries of some particular range. So maybe if we're concerned with the set of numbers that are between, in this case, between 20 and 40, we can actually use a combination of these operators to check that. So the first case that we've got right here, we're saying if x is greater than or equal to 20 and x is less than or equal to 40, then we can go ahead and print out the statement that x is in the acceptable range. And we can also see in the if statement, we're saying if x, and then we see the greater than or equal to operator, and then 20. So we're doing that comparison there. And we're saying if x is less than or equal to 40. So we've got that other comparison on the other side. So essentially what we're doing is we're saying that 20 and 40 are like our bounds on each side. And we want to make sure that the number is between those two numbers. Alternatively, we can say if x is less than 20 or x is greater than 40. So with this one, we're saying if x, and then we have the less than comparison operator, and then 20. So we've got one comparison on that side. And then we've got x greater than 40 using the greater than comparison operator. We're going to go ahead and check that comparison on the other side of an or statement. So what this one is going to do is basically say if we have the number that's on one side of those bounds, so anything that's less than 20, or we have a number that's on the other side of those bounds, so anything greater than 40, that's going to tell us that the number is outside the acceptable range. So this is going to be the general rule of thumb when it comes to trying to make a check of some kind like this, where we're checking for an acceptable range. If you're checking for anything that's inside the range, you're going to be using logical and, but if you're checking for anything that's outside that range, you're going to be using logical or. So let's go ahead and minimize this, and we're going to go ahead and put this together in another sample program. So right here, we'll go ahead and create a new project, and this will be a new Java project. For this one, we'll go ahead and call this one our boundary check. Go ahead and finish this. And so right here for our code, we'll go ahead and remove some of the extra comments that we're not going to need. And right here, we will go ahead and put in some integer value that we can go ahead and check against those boundaries, that 20 and 40. So let's say we start off, we've got our integer. We're going to call this x, and this will be equal to, let's say we start off with a number that's in those bounds. So we'll start off with something like 30. And then right here, we'll go ahead and put together those conditional statements. So we've got our if statements, and then the print statements we will conditionally execute. So we're going to say if this x is greater than or equal to 20, and this x is less than or equal to 40. So that's going to tell us that the number is between 20 and 40, including 20 and 40 themselves. We'll go ahead and say system.out.println. we'll say that our x is in the acceptable range. And then the alternative, we're going to say if x is less than 20 or x is greater than 40, we'll go ahead and say system.out.println. We'll say x is outside the acceptable range. So now if we go ahead and run this, right now x is going to be 30. So if we check right here, x greater than or equal to 20, well 30 is greater than or equal to 20, that's going to be true. X less than or equal to 40, 30 is less than or equal to 40, so that's also true. So because both of these are true, we will go ahead and print out x is in the acceptable range. If we go ahead and do these checks, we're going to say 30 less than 20, that's going to be false. 30 greater than 40, that's also false. So this entire one's going to be false. So if we go ahead and run this, we're going to see 30 is in the acceptable range. And then if we go ahead and test this with a couple of different values, so we've got 30 right here. Let's also go ahead and test this with 20 and 40 themselves, and then we'll also test it with a number less than 20 and a number greater than 40. So we'll check 20, go ahead and save that. So essentially we're going to check this lower bound to make sure that that's working properly. So if we go ahead and run this, we'll see 20 is in the acceptable range. That makes sense because we're doing greater than or equal to, and 20 is equal to 20. With this one, we're saying 20 less than or equal to 40. Well, 20 is less than 40, so that's also going to be true. So we'll go ahead and print that out. And then, of course, with this one, these two statements will continue to be false. If we do the opposite, we're going to say int x is equal to 40. We'll go ahead and save that and run it. We also see that 40 is in the acceptable range, so that's going to match up here. So we're saying 40 less than or equal to 40. Well, 40 is equal to 40, so that's going to be true. And then back over here, 40 greater than or equal to 20. So 40 is greater than 20. It's going to make that true. And then for these two, both of these are going to be false. So we're not going to execute this statement. And then finally, we'll go ahead and test it out with anything that is outside that range. So we'll try something like 10. So for this one, we'll go ahead and run this. And so we see 10 is outside the acceptable range. So we're going to do 10 greater than or equal to 20. That's going to be false. So because this is false, we can immediately stop here using that short-circuited evaluation. If we want to go ahead and check this one anyway, just to make sure we understand the logic, we see 10 less than or equal to 40. Technically, this is going to be true, but because the first value is false and we're using logical AND, that's going to make the entire expression false, so we're not going to execute this statement. But right here, we're going to say if x is less than 20, so we're doing 10 less than 20, that's going to be true. We're using logical OR, so again, with short-circuited evaluation, we could stop here. But to go ahead and check this one as well, we say 10 greater than 40. That's going to be false, but we're not too concerned with this because the first value was true, so that's going to make the entire expression true. So we're going to go ahead and print out this statement to the console. So we see 10 is outside the acceptable range. And then finally, we'll go ahead and do the opposite case. This will be our last case. We're going to do 50. So if we go ahead and run this, we'll see 50 is outside the acceptable range. So looking over at this, we've got 50 greater than or equal to 20. So that's going to be true. So because that's true, we need to go ahead and check the next condition as well. So we're going to say 50 less than or equal to 40. That's going to be false. And because it is, since we're using logical AND, that's going to make the entire expression false. So we're not going to execute this statement here. So then we come down to the next one. We're going to say 50 less than 20. That's going to be false. So because that's false, we have to check the next one. We're going to say 50 greater than 40. That's going to be true. And because that's true, and since we're using logical OR here, that's going to tell us that the entire expression is true. So we can go ahead and print out 50 is outside the acceptable range. All right, so at this point, this is going to wrap up everything for our logical operators. In the next video, I want to take another look at some expressions kind of like this, where we're doing some boundary checking, but I'm going to expand on this to look at the bounds of not just some arbitrary numbers like 20 and 40, but more specifically the bounds for our different data types, our numeric data types. In addition to that, we're also going to look at a couple of useful methods that provide some conditional coding with our floating point data types as well.